In this lesson, we're going to be simplifying radical expressions. So we're going to be talking about square roots, cube roots, fourth roots, fifth roots, and anything past that. So if you're asked to simplify the square root of 25, why does it become 5? So there's a couple ways to look at this. The square root of 25 is square roots. You're always looking for a number times itself. And what is that number that will get you 25? And so 25 consists of 5 times 5. So square rooting, we're looking for two of the exact same number, and we got that right there. So 5 times 5 gets us our 25, so it consists of two 5s, so it becomes 5. There's a second way to think of that, is if you're square rooting 36, why does it become 6? Well, another kind of mathematical way to do this is, if we take that 36 and we break it into the 6 times 6, 6 times 6 is also 6 squared. So if we rewrite that and look at it this way, is, let me rewrite that a little bit, is 6 squared is the same thing as 36. And it's exact same two numbers. And the square roots and squares are exactly the opposite, so they undo each other, leaving you with whatever's left on the inside. So, for example, if you have square root of 16, it's basically 4 squared, and squares and square roots will cancel each other, so it turns out to be 4. So if you're trying to square root negative 36, well, is there a way to write something squared to get a negative 36? And the answer is no, because even if you try to put a negative 6 in here, a negative 6 squared is actually a positive 36. And a 6 times 6 is not negative 36. The only way you're going to get that is to have a negative 6 and a positive 6. So for right now, we'll be able to do it eventually, but for right now, this is a non-real number. So we'll come back to that. And you can't square root negatives. You can't take a fourth root, because anything that you're going to have an even number of negatives, they're going to cancel each other away. So that won't work. But, and we'll do the negatives with the odd in a second, but if you cube root an 8, you're looking at 3 of the exact same number that's going to get you an 8. So you can think of it as, well, 2 times 2 times 2. So 2 times 2 times 2, that's 3 of the exact same number, just like up here it was 5 times 5, gets you your 25, so it square roots to 5. This will cube root to 2. You can also think of it as what number cubed, because cubing and cube rooting will undo each other, just like squaring and square rooting will undo each other. So is there a number that you can cube to get 8? Yes. So 3 of the exact same number is 2, so your answer will be 2. So what if you have a negative attached to that? So if you have a negative attached to that, can you take a number cubed? Is that possible? So is it negative 2? Because we already know that 2 times 2 times 2 gets you 8, but if you throw a negative into that, a negative times a negative times a negative will actually keep a negative 8 on it. So this is set up perfectly, and it's only because you have an odd number. If you had an even number, if this was a fourth root or a square root or a sixth root, you wouldn't be able to do this. But if it's a third root, a fifth root, a seventh root, any odds, this is okay. So this cube roots to negative 2. Alright, so what if you have a little bit more complicated version of this? You're doing the cube root of this fraction. So if you're cube rooting a fraction, the good news is that you can just break this up into two individual parts. You can cube root, and we'll just apply the negative to the top, really wouldn't matter. But we can cube root the negative 8, totally separate from the bottom. So a negative times a negative times a negative, so we know we're going to get a negative out of that, so there's 3 negatives. And then what times what times what gets you 8? 2. And then here, it's what times what times what gets you 27. and that turns out to be 3. So fractions are basically just two problems in one. Break them up individually, and then you can rewrite your fraction. This also will work with variables. If you are square rooting an x squared, it looks just like this problem up here. So squares and square roots undo each other. Squares and square roots undo each other, leave you with whatever was on the inside. So if it gets a little bit more complicated, x to the 4th. So you're kind of thinking of it as, what can you rewrite this as to get x to the 4th? Because if you can come up with a value here, then that square and square root will cancel each other and just leave you with whatever's inside the parentheses. So if you remember your powers to powers property, that you're going to multiply these two together. So squares and square roots will cancel, and you're left with whatever's inside the parentheses. So that'll become x squared. All right, and there's definitely something else that's kind of happening here, and maybe you can figure out this pattern. So if we do another. X to the 6th. So can you come up with a way to make it look like this? So power to a power, is there a number we can put here that multiplies to the 2 that'll get us a 6? The answer is 3. So squares and square roots will undo each other, and this will be left with x to the 3rd. And again, there's definitely a pattern. There's a quicker way that if you get comfortable with it, you can kind of start to apply it. But let's do a couple more. How does that work for cube roots? So cubes and cube roots work exactly the same as squares and square roots. They undo each other, and you're left with whatever is inside the parentheses. So if we have a cube root of x to the 6th, is there a way that you can write this as cubed this time? So the cube and the cube root can cancel. Power to a power, this would need to be an x squared. So that'll be an x squared. So there's definitely a shortcut happening. Here you're looking for groups of 2. So basically you can take this 6, divide it by 2, and that'll get you your 3. Here you can take the 6, you're looking for groups of 3. How many groups of 3 can you get out of that? Essentially division, so you can divide it by 3. That'll get you your square. So let's see if we can apply the shortcut. So cube root of x to the 21st. So if you want to write it out, you're looking for what times what's going to get you 21, and that is 7. Or you can think of it as 21 divided by the 3 is going to get you x to the 7th. All right, so you can also do this with numbers and variables mixed together. So numbers work like numbers, variables we're going to do the division with it. So is there a cube root of 8? Yep, 2 times 2 times 2. So that'll equal a 2. And then we have x to the 15th. We could write it again like this if we wanted to. X to what power is going to get you, times the 3 is going to get you 15. Or you can just divide. 15 times divided by 3 is going to get you a 5th power. And that is a little bit of simplifying radical expressions.